So I figured while this was still fresh in my mind, I would kind of just go through this just to help out anyone else who is kind of struggling with this issue for this particular problem, just because it's more of a complex one as far as Calc 1 goes. So we have the equation x squared minus xy plus y squared equals 3 represents a rotated ellipse. That is an ellipse whose axes are not parallel to the coordinate axes. Find the points at which this ellipse crosses the x-axis and show that these tangent lines at these points are parallel. So obviously a lot of words. What exactly does that mean, right? Well, find the points at which this ellipses crosses the x-axis. All that means is, we're trying to find the x-intercept, right? We're trying to find where y equals 0, because that's where it would cross over the x-axis. And then show that the tangent lines at these points are parallel. Well, we know the tangent lines are used for the derivative, right? It's the slope of the tangent line that is the derivative. And then points are parallel just basically means that the slopes are equal, right? Because if the slopes are equal at those points, then they'll increase and decrease at the same rate, and thus they will never, of course, cross each other or intersect each other at some distant point, and thus they will remain parallel. So we can go over to kind of a drawing. So we'll kind of just go over what an ellipses is. If you forgot, ellipses kind of looks like this. Obviously, this is more like a really bad potato. So but this is kind of roughly what it would look like. You kind of lose the geometric properties with drawing kind of that rough. And then a rotated one is you want to kind of rotate it like 90 degrees, so it would look kind of like a little kind of almost lemon shaped, kind of a little more oblong. And then the x-intercepts, of course, where it crosses the x-axis, and of course where y equals 0, so that's right there. And if we draw a tangent line, if I can just kiss the side, oh, this side is a little bit too deep. Let's back, maybe more like that. Okay, that's a little bit better. So again, not my cleanest drawing, but you get the idea. These are parallel because their slopes are equal, right? Say this slope is like 1, this slope is like 1, so they'll never touch. Again, that's at the x-intercepts there, y equals 0. Obviously, this is not correct, but again, you get what I'm trying to show. So let's take the original equation, right? So obviously, x-intercept, y equals 0. Again, what does that mean if we're trying to show that mathematically? That just means if we have the original equation right here, and if you're wondering, this is negative xy, that's what actually does the rotation for the ellipse there. So all this means, of course, we just want to set y equal 0. So simply put, we just do that plus 0 squared, we equal a 3, and then, of course, that just leaves us with x squared equals 3. How do we get rid of this? We just square root both sides, which leaves us with x equals square root of 3, which means it would actually be plus minus square root of 3, right? So what those points then be? Would be negative square root of 3, 0, and square root of 3, 0, right? So these are the points. Is that what the answer is? Yep, you can see right there. That is the answer. But we also still need to show that the tangent lines at these points are parallel. Again, that means that their slopes are just equal, right? So how do we find the equation for the slope so we can plug in these points? Well, that's just the derivative, right? So we just need to differentiate the original equation here. So again, we'll take x squared minus xy plus y squared equals 3. And we'll just do the derivative. So x squared turns into 2x minus xy. We know 1 times y plus, because it's product rule, y prime times x plus y2 should just 2y. Don't forget to tack on the y prime there. Equals derivative constant is 3, or rather it's 0. Derivative constant 0. 2x minus, and then we'll combine and simplify. So again, remember we want to apply this negative to the entire thing. So we'll get minus y plus xy prime plus 2y times y prime equals 0. Now we just want to get the y primes isolated, so we'll add y and subtract 2x. So we'll get, oh, I did not properly apply. Don't forget, again, because this is a negative, this whole thing's negative, so this xy has to be negative. So we will add the y, subtract 2x. That'll leave us with xy plus 2y, y prime, y minus 2x. Now we just want to factor out the y prime. That leaves us, it's a rough one, x plus 2y equals y minus 2x. Now we just divide this to cancel it out. That leaves us with y prime equals y minus 2x over negative x plus 2y. That's a little ugly though, so let's rewrite it as y minus 2x over 2y minus x. That looks a little bit nicer, right? So now we have the derivative of the original equation, and just remember, something I always like to remember that my professor said is that the derivative of an equation is just the slope producing formula for that equation. So now we just want to produce the slopes. We have the original points. Again, it's negative square root of 0 and square root of 3, 0, right? So we just want to show that if we plug these values in for y and x, this equation right here, the derivative should produce the same value. So let's try it for negative square root of 3. We get, so let's see, 0 minus, actually let's just do this. I think it'll be a little bit easier to follow. So y minus 2x over y minus x. Then we just plug in 0 for y. We plug in negative square root of 3 for x. Again, plug in 0 for y minus a negative square root of 3. Of course, that all simplifies down to, actually these negatives should cancel out right here. Get a 2 square root of 3. Negatives should cancel out. This is a 0, so this should just square root of 3. The square root of 3's cancel out, so that should just leave us with 2. So for negative square root of 3, we get a slope of 2. So let's try it for positive square root of 3. So again, we have y minus x over 2y minus x, right? Then we plug in y equals 0, plug in the positive square root of 3, plug in 0 minus positive square root of 3. And again, we find here that the top should be negative 2 square root of 3. And we have 0 minus negative square, yeah, minus the square root of 3. That equals that. So we cancel out the negatives. We cancel out the square root of 3's. That leaves us with 2. So y prime equals 2, y prime equals 2. Thus, we see that these slopes are parallel. Thus, because the slopes are equal. And that's really all you have to do to prove that. Hope that this helped.